Okay, so let's talk about models, right? So we did this already. We talked about models in UML. We talked about models representing in relational databases. We talked about models representing in object-oriented technology on the server side. Now there's models also on the client, right? So we have data has to be represented, has to have some structure, wherever it lives, right? Whether it lives on the client, whether it lives on the server, whether it lives in the database, or in our conceptual models of UML, right? So let's create a model in Typescript. It's very easy. You just create a class, very much like you create a Java class. Here would be a TypeScript class, right? So let's under the source directory, we're going to create this file. So let's do that. So in here. In source, we'll create a new file in the directory models. And yes, we want to put it in Git. There it is. And what we're going to put in there, we're going to put this content. Now, notice that I have deliberately made the variables capital. See that? If this was Java, I would make them all lowercase using camel case. It's a norm, right? It's a specification. In JavaScript too, typically these would be all lowercase as well. But I know that the API I'm going against, right, capitalizes all their variables. See that? Okay, so their database, their schema, uses all the input, all their fields are capitalized, and I'm going to have to do a mapping between their schema and our schema. Right? This is my schema, right? This is the way we are representing the data in our application, and I'm going to have to map their schema to my schema, right? So I could be more more rigorous and put all these lowercase the way it should be, and somehow I would need to convert this, right? I would need to say, oh well, the lowercase title matches with the uppercase title. I don't want to have to bother with that, so I'm just going to take their schema and I'm going to match their schema verbatim, right? So so the mapping will be minor, so I don't have to deal with this. Make sense? Right? So this is a no-no. Typically, I would want to make them all lowercase, but again, it's here too. Right? The ID is capitalized. Typically, you would not. That D would be lowercase, but that's fine. All right. So I have our model. Now we want to be able to go and fetch data from OMDB. We're going to want to fetch data. And we already know how to do that, right? If I know the URL, I would like to be able to do this programmatically. I don't want to have to do this manually like I'm doing it here. I want to do it programmatically. Yes? Right? So let's do that. I want to use that URL and be able to search for Batman and get back an array. So let's do that. So to do that, we're going to encapsulate all data access in a service, just like we did on the Java side, right? Right? It is good practice, right? It's industry standard, good practice that you encapsulate all data access in specialized classes. Like for instance, when you're accessing the database, it's a good idea to put a DAO in front of it. And when you're accessing through a service, right, through URLs, it's a good idea to encapsulate that in a web service. Yes? And each one of those layers is very specific of what they do, and that's all they do. The DAO uses either JDBC or JPA to talk to the database, and that's all it does. Right? And the web service on the server, that's all it does. It maps URLs to data retrieved from the DAO, and that's all it does. Yes? So same thing here. We want to go fetch data to a remote API. Well, there should be a single place of maintenance that's the only thing it does. It goes and fetches data. And we only want to fetch two things, either a list of movies that match a criteria or fetch a particular movie based on some ID. Yes? All right, so let's do that. We're going to put that inside of a movie.service.client. We are a client, meaning there's a server on the other side who's actually fulfilling my requests. We are on the client side of that, right? We would know how to build this, right? We would know how to build the server side. We did that already, yes? We learned how to do that a couple weeks ago, right? Using Java REST controllers. So I don't know what they use on that side. Maybe they're using PHP, maybe you're using Ruby, maybe they're using Python, maybe you're using Java, maybe you're using Node.js. I don't know. It doesn't matter because we all speak JSON. It doesn't matter. That's the beauty of using an intermediate representation. Yes? Okay, so and all services are going to live under a particular directory called services, just like we did on the server side. So under here, we're going to create a new file. Okay, here we're going to create a service, our first service. Implement it as a class, and we'll call it as omdb movie service. Oh, okay. So by default, it'll take the name of the file, right? But I want to stick to what I wrote in my slides, so this should be called client. Okay. I'm going to hardcode here the URL as a local variable, and with no s, I'll just say ampersand. So with my key, I'm going to use my key. Do not use my key. Right. So I'm going to just copy it from here. There's my key, and I'm going to paste it here. There we go. And I'm just going to append either s equal if I'm searching for a movie with a particular title, or I'll use I equal if I have the IMDb. Okay? All right, I have that. Now I'm going to create two functions. One that takes a keyword and one that takes the ID of a movie. Okay, this one takes a keyword, the other one takes an ID. All right? All right, excellent. I think it doesn't understand my version of JavaScript, so I'm going to change, we're going to preferences. I'll say languages, and the JavaScript version is assuming 5.1. I'll go to ECMA 6, so it stops bothering me about syntax. Okay, those two functions. All right. Now, if this were working on the server, we would be, parsing a URL, right, and then using JPA to retrieve and fetch data from our database. Yes, but that's what omdb is doing. We're not going to be doing that. We're going to be sending those requests, and omdb will search the movies that match the criteria, and it'll spit out JSON for us. Okay, so let's see. Also, we're going to make it injectable. This is equivalent to being able to auto-wire in Java, right? When in Java you can say auto-wire some repository, yes? And the reason you can auto-wire is because that thing that you're auto-wiring has either been tagged as a component or has been tagged as a service. Okay, like many of you have learned about how to inject DAOs, right? You have to tag it as a service, and then you can inject it, right? You can auto-wire it. So that we can auto-wire, we need to tag this as injectable. Okay, right? This is annotations, just like we have annotations in Java. Now we have annotations in JavaScript, which is pretty cool. Okay. All right. What else do we need to do? All right, so let's implement first find movie by keyword. And this is the implementation. I'm just going to copy it over. Actually, my implementation doesn't, it assumes no body. There we go. So what it's going to do, it's going to generate a get. That's what we're doing here in the browser when we're doing this. This, if we inspect what the browser is doing, we can look at the underline request here. Oops, let's put it on the right-hand side. We can look at the network traffic. Right, if we refresh, the page, notice what's happening. The client, the browser, is sending a query. There it is. That's the query. You can see the headers. It's sending a GET, right? And that's the URL that was sent over. And the response, the raw response, was this JSON object, this JSON string. Yes? Right? So we want to do exactly this. Send a GET with that URL. But we want to do it programmatically. So how do we do that? Well, from JavaScript, we can use a function called fetch. Fetch, by default, takes as argument a URL. Right, this is the URL. And by default, it will send a GET. If you want to send a post, a put, a delete, you have to reconfigure it. But by default, it sends a GET, which is exactly what we want. Okay? So what are we sending? We're sending this URL, which is that one, and we're concatenating s equal and the keyword. Everybody good? We're just sending a request. This, notice what it returns. See that? See the .then? Where have we seen that before? We've seen it in Mongo, right? When Mongoose was connecting to Mongo, right? It was doing it asynchronously, right? Because it was the Node.js server communicating with a MongoDB server, and usually they're not running on the same machine like I had it. Typically, one is running, in Arizona, and the other one is running, somewhere in Asia. Right? They're not necessarily co-located geographically, so it's an asynchronous call. Well, this is also an asynchronous call. This is somebody's browser. I don't know where they're running from. It could be anywhere in the world, and they're communicating with my server, which presumably is I'm sorry, not with my server. They're communicating with omdb server that I have no idea where it's being hosted. Right? So these are two machines talking to one another over wire. So it's an asynchronous call. So this fetch returns a promise. Right? Again, this is a very common pattern in server programming, in database programming. And what these folks have done is that they've copied these very mature ideas of promises, of asynchronous calls and things like that, and they've built it, right? They've moved it over, also available on the client. Very, very powerful. Okay, so it comes in. This is presumably the response that comes in back from the server. That response has a metadata. It has headers. It has a body. It has a whole bunch of things. And in the body, presumably, hopefully, there's JSON embedded in that body, right? And we're saying, well, parse it or try to parse it as JSON. Try to parse it as JSON. And whatever comes back from there, right, give me that JSON as an object, as a parsed JSON object. So this is what it returns. So this is what it returns. If this syntax bothers you, you could be a little more specific, and you can literally say return that if that syntax bothers you. There we go, with a semicolon at the end. Okay? Everybody good? All right. All right, so we have one of them. Let's do the other one. Let's do the find by ID. So I'm going to use the other syntax with no return. So this one says take that same URL, but appended I equal IMDb. Right? And then try to parse the JSON, and that's what you're going to return, the JSON. Everybody good? All right, so all data is encapsulated in this one injectable service. Anybody can ask for it using inversion of control, using AutoWire. Right? Just like in Java you can do AutoWire, here too. The syntax is different, but it's the same idea. It's the same concept. Okay? In Java you use @AutoWire. Here use @injectable, and then you ask for it in the constructor. Right? Before we do that, this service, this new service, needs to be declared at the application level as a brand new data service, as a data provider. It needs to be declared so that the rest of the framework knows about it, so that it can auto-wire it. Right, so to do that, we're going to have to declare it at the application level. To do that, there is a module. This is a configuration file. It allows you to declare all sorts of things. One of the things you can declare is data providers. Okay? Client. There we go. Okay, so it loaded it. Never mind this syntax. It doesn't like double quotes. Ever still with me? You lost anybody? Okay. All right, we got services. Let's start using services to build our first search component. Right? Let's start searching things.